negative. Even minus 1 million squared is positive. The least you can get is 0 squared, which is 0. So at the minimum point, x minus 2 must be 0. Therefore, x is equal to 2. Also, y will be 3 times 0 squared plus 10, which is 10. So the minimum point is x comma y, which is 2 comma 10. Now this is the minimum this graph will have. 2 for x, 10 for y, and it goes back up. So we know that it doesn't cross the x-axis. We know the minimum points. Do we know what point it crosses the y-axis? And that's the point where x is 0. And already, because we know this is the equation of the line, at the point where x is 0, what's y going to be? 22. So we can happily plot this graph now and state all the points and get all the max. X, y, 22, 10, 2. It doesn't cross the x-axis. And I know that this point here, where these two meet, will be the minimum point. And I know that it crosses the y-axis at that point. And I know that it doesn't cross the x-axis. And because this is a minimum point, we know it's going to go this way because the coefficient of x squared is a positive. So it's a U shape. So it goes this way, and that's the minimum, okay? It goes up from there. It doesn't go below this point. And this is where it crosses the y-axis. All right, so we've been able to successfully plot the curve y equals to 3x squared. I've lost the question. Minus 12x plus 22. All right, that was easy, wasn't it? Like I was going to say, another thing we get from the completing the square problem is that it tells us whether it's been translated to the right or left, or up or down, and if it's been rotated or magnified, as you may want to call it. So briefly, because this is something we'll be talking more about when we plot graphs. Regularly, it's common, what am I saying? It's common to know that for y, every quadratic takes its behavior from the graph y equals to x squared. Y equals to x squared is a very humble quadratic that has its minimum point at x equals 0, y equals 0, and it has its roots at x equals 0, x equals 0. Okay, it has two real roots, same root, because d is 0, b squared is 0, a is 1, c is 0, so d is 0. Now this is the curve y equals x squared. Okay, what happens when you say y equals to x minus b squared? I'm using that now because we are coming from this kind of a problem where you complete the square to have x plus b or x minus b all squared and so on. All right. So what is the difference between y equals x squared and the graph of y equals x minus b all squared? All right, that is simply telling you that now we are still going to have the same kind of curve, exactly the same kind of curve, but we are shifting it to b plus b. Okay, it's going to now, instead of crossing the y-axis at the point x equals 0, it's going to cross the y-axis. It's going to cross, it's going to, how do I say this now? instead of having its